All right, folks, this is the lecture for section 7.2, integrating trig functions, day 2. Today we're going to focus on tangents and secants for the most part. It's important that you understand that each of the following that I'm going to show you today, or in section 7.2, uses nearly identical techniques when you replace all of the secants and the tangents with cosecants and cotangents. So, a couple of things before we get started. There's mandatory trig identities that you have to know before you even begin to do a lot of these integrals. It is the Pythagorean identity that connects tangent squared and secant squared. And equivalently for cotangents and cosecants, we have cotangent squared plus 1 is equal to cosecant squared, or its variations. So commit those to memory, folks. Do not start these problems without knowing those. Okay. We're going to start off in this video with just the powers of tangent. So let's take a look and see what happens as we progress through powers of tangent. Now, we've already seen some of these. In order to integrate tangent, I want to note one thing. Note, we never integrate tangent directly. This is almost always manipulated into some other form. Now you should know how to integrate the tangent function, tangent to the first power. This you rewrite as sine over cosine. You do a w substitution. W here is cosine x, so that this becomes negative the integral of 1 over w dw. If you're not following that, dw is equal to negative sine x dx, and if you do a proper substitution, you'll arrive at that conclusion. Then this becomes negative the integral, let's integrate it, negative the natural log of the absolute value of w plus c, which is negative the natural log of the absolute value of cosine plus c, and if you bring that negative coefficient up as an exponent on cosine, again, please do not confuse cosine to the negative 1 with inverse cosine. That's not what's happening in this problem. This is the natural log of the absolute value of the secant plus c. And there is our antiderivative for the tangent function. Now, not only should you be able to do that, you might want to consider memorizing that outcome. Okay. The next one is tangent squared. This might be the easiest of the powers of tangent to integrate. Again, we don't integrate it directly. We replace it with a Pythagorean identity. Tangent squared is equal to secant squared minus 1. That is this relationship here. And what we have is the integral of the secant squared dx minus the integral of 1 dx. So more mandatory trig. This is sort of the calculus of trig. You need to know that the derivative of the tangent is the secant squared, which directly relates to the antiderivative of the secant squared, which makes this the tangent of x minus x plus c. And that is our antiderivative. For tangent cubed, this one is also pretty straightforward. This is similar to an odd technique. What we're going to do is we are going to, and by odd technique, I'm referring to the odd technique that we used in sines and cosines. What we're going to do is siphon off 1 power of tangent, and then use a Pythagorean identity to rewrite tangent squared using that mandatory trig. This is secant squared x minus 1 times the tangent of x dx, making this the integral of secant squared x tangent x dx minus the integral of tangent x dx. Now, for this first integral, we're going to let w equal the tangent of x, because dw is secant squared, which is sitting right out front here. And this becomes the integral of w dw. And then if you know what the antiderivative of tangent is, you can just go ahead and throw that in there. The natural log of the absolute value of the secant plus an arbitrary constant. When we integrate this w, we'll get w squared over 2 minus the natural log of the absolute value of the secant plus c, which is tangent squared x over 2 minus the natural log of the absolute value of the secant plus c. Or equivalently, let me pick a different color here. One half tangent squared plus the natural log of the absolute value of the cosine, although typically you're going to see it written this way. And that's tangent cubed. Tangent to the 4th power starts off with an even technique, although we don't have a double angle formula for tangent squared. There is one, but we don't use it in this course. This is secant squared, this is tangent squared times tangent squared dx. And then I will use a Pythagorean identity. Maybe that's misleading with the even technique. I'll use a Pythagorean identity on only one of these. This is secant squared x minus 1 times tangent squared x dx, which is the integral of secant squared tangent squared minus tangent squared x dx. We're going to break that into two integrals. This is the integral of secant squared x. I'm going to rewrite it like this. Tangent x quantity squared dx minus the integral of tangent squared x dx, which we already know from up above. And here we're going to do something very similar to the previous problem. We're going to do a w substitution for tangent x. Remember that dw is secant squared x dx, and this is going to become the integral of w squared dw. And then if you have this one memorized, that's cool. If not, remember that this is the integral of secant squared x minus 1, making this 1/3 w cubed, where w is the tangent of x, minus the integral of secant squared, which is tangent, and then distributing that negative sign, plus the integral of 1, which is x, plus c. And that is the antiderivative for tangent to the 4th. So there are a couple of things that you should do on your own now. See if you can go a couple more tangents up in power. Can you do tangent to the 5th? Is it similar to one of the above techniques? Does it use some similar stuff? I bet you could do it. And maybe even tangent to the 6th. Try those. The other thing that you should do is go back and replace all those tangents with cotangents. That is, can you do the integral of cotangent? Can you do the integral of cotangent squared? Can you do the integral of cotangent cubed? ... That is to say, go back and do A, B, C, D again, but replace them all with cotangents. Give that a shot.